1S1. Any unit in District 2, Zone 2, having a chainsaw and some availability to help out one of our own, please.
Just clearing my 38. I'll be on a 1019 to HCS.
1021-4642, priority 3,
Code
please.
2 for a 1055, no contact, well-being check on one of
Code 2
our
for this
own.
location. Could I have a unit 1025 with me for Code 2? Bring in some water.
Hi, this is Chris from US Preparatory. Today I'm going to show you how to tune an antenna system, a mobile antenna in this case, for the PEG radio system. Today we're going to be using a new Motorola Spectrum, a 42 to 50 megahertz version, and I'm going to show you how to tune the antenna properly with an SWR meter. And this particular car, we used an HL1 remote head kit mount, so that basically means that the radio is mounted under the seat in this vehicle. So we'll be connecting our SWR meter between, or in line rather, between the antenna and the radio itself. So, okay, let's get started. Different meters are labeled, different SWR meters are labeled different ways. They might use different terminology, have a different amount of ports, and a different amount of range that they can work in. I'm going to be using this meter here, which actually is a huge range of between 1.9 and 525 megahertz. And therefore, because of that range, it has ports that separate low and high, these being the lower frequency ports, these being the high. It's selected accordingly for the frequency range that we're going to be in, which of course for the PEG radio system is between 30 and 50 megahertz. In this particular install, we're going to be including this, or tuning this antenna rather, to the 48 megahertz range. So, the first thing we need to do is connect the meter in line. So we're going to disconnect the antenna from our radio, and we are going to connect it to the antenna port, which is right here. Now I'm using an adapter cable because it's using a mini UHF connector, a Motorola mini UHF for this antenna. And because of that, we're going to use an adapter cable. Okay, the other cable, which is actually coming out of our transmitter port here, transmit port, that's going to go to our radio. First thing we need to do is calibrate the meter itself. So to do this, you're going to put the meter on the calibration setting. On this meter, it happens to be labeled SWR set. You can see that. Put it on SWR set. Now we're going to key the transmitter and we're going to adjust the calibration dial. Some meters don't have calibration dials for a smaller preset set of frequencies. Say if it's an amateur radio SWR meter designed for the UHF and VHF band, it won't have a calibration dial. Most SWR meters, however, do, especially ones that are designed to do a broader frequency range or a lower frequency range. So let's get this this meter calibrated. Okay, the first thing we're going to be doing, as I mentioned, is putting the meter on the calibration setting. We're going to transmit, and we're going to use the calibration dial to make sure that the needle is right on the cal line over to the right. I'm going to switch the meter over to the SWR setting, and we're going to transmit to see what the SWR reading is. Now we're looking at the top scale between 1 and the infinity symbol, or the calibration symbol, very top scale. Okay, we get an SWR of 10. That is atrocious, and the reason why it's atrocious is because when antennas come new from the factory, the length of the whip is as long as it needs to be to tune the antenna to the lowest frequency range it was designed to perform in. In this case, it's long enough to make sure that this antenna can tune to the 42 megahertz portion of its range. So we need to trim quite a bit off of this whip. Alright, some of the tools that you're going to need for the cutting of the whip and doing the adjustments on the antenna for a proper SWR it really does depend on the whip material. But the most universal way of cutting a whip is either with a small pair of bolt cutters or a bench grinder. Those are the two safest and best and most accurate ways of cutting it. An angle grinder could also be used, but they're a bit dangerous. There's really nothing holding that whip unless you have a vise or something to clamp it into. Now you can use an old pair of linesman pliers. I say old because it likely will damage the cutting edge here of the linesman pliers. But this only works on smaller diameter, less dense whips. Larson Antenna Company has a much more flexible whip and is only a 2.5 millimeter whip material that will cut with an old pair of linesman pliers. But the Motorola whips and whips of similar size, this is actually a 3 millimeter whip, much more rigid, and because of that, they do not cut with anything but either high leverage tools such as a bolt cutter or an angle grinder, or even better, a bench grinder. So I'm going to be doing my cutting on a bench grinder. Okay, make sure when you put the whip in after cutting it that it's bottomed out, and then tighten the set screw. Alright, back in the vehicle, we just trimmed off a significant amount off the whip. Want to make sure we put the meter again back in the SWR calibration setting, which in this meter, in this case it's SWR set. We've got to recalibrate each time we cut the whip. Hit the transmit button. Going to make sure we put that needle right on the calibration line. Switch the meter over to the SWR setting. You can see it's getting a bit better now. Now we're at 3 for an SWR. We're going to repeat this process, trim off a little bit at a time. When we start getting close, we'll start trimming off no more than 1/4 of an inch at a time. Again, bottom out that antenna whip in the ferrule and snug it up. Now we should be getting close here. Let's recalibrate the meter. Switch it over to SWR setting. Alright, now we're starting to get into the efficiency zone here. I like to have the SWR of my antennas 1.5 or below. That's not possible on every vehicle with every antenna. It really does depend on the vehicle's construction, the way it's set up, what's on the roof, and other things, other obstructions that are on the roof. But we are getting close. Okay, when you put the whip into the ferrule of the antenna, there's a set screw, of course, on every antenna. Some actually have 2. You loosen that. There's an adjustment here. On the Spectrum, it's quite a bit. It's over 1 inch. That adjustment is to compensate for a mistake made if you cut a little bit too much off the whip. And this is why I recommend when you do your cutting and you start getting very close, you want to make sure that you only cut off about 1/4 of an inch at a time. This way, if you put it in, and like I mentioned, you want to get into the habit of pushing that whip all the way down to the base and then tighten it. This way, if you happen to make a mistake when you cut it, you have the opportunity to bring it up the 1/4 of an inch that you just cut off, which allows you to readjust the antenna back to its optimum setting or its optimum tune point. Alright, this should be the final time now. Put the meter in recalibrate. Switch it over to SWR. Oh, that's great. Got a 1.2 and a half to 1 on the top scale there. That's pretty good. That's likely about as good as you're going to get it. It is possible to get a better match if we continue to cut, but you will reach a point, and I think we're at that point from experience now. It tells me to stop cutting. A good indication is if you cut and you don't notice any movement on the meter change after you cut another 1/4 of an inch off, or worse, when you cut it off, the meter starts going, the SWR starts going in the opposite direction it should be, which is back up. that means you cut off too much. I just wanted to pass along a couple of tips to you to maybe save you some hassle or a possibility of a problem in the near future if you were to say switch an antenna that you had previously had on one vehicle and maybe switch it to a new vehicle or another vehicle that has a mount. A couple of things. The antenna itself is not really transferable between vehicles. If you had matched up an antenna for one vehicle and you would move it to another, that's not to say that the SWR, the antenna match, is going to be the same on both vehicles. The vehicle itself is different. Every one is different. Depending on what's on the roof, whether it's a ladder rack, a roof rack, or some other obstruction, it's going to change the dynamics of the antennas matching in the way it matches up to that particular vehicle. So be very cautious when you take an antenna that works on one vehicle and put it on another. I would recommend, if you're going to do that and share an antenna between vehicles, that you at least check to make sure that the match, the SWR ratio, is in an acceptable range. That's highly recommended. The other thing is that if a particular antenna, such as this Motorola Spectrum, matches up perfectly on your vehicle, and say it had a whip length of about 47 inches, that doesn't mean that another brand antenna cut at 47 inches is going to be the same. In fact, there's every likelihood it's not even going to be close, because each brand antenna makes the internals, the coil lengths, different, and they're not going to be a universal whip length that's going to work on all brand antennas. Okay, so make sure that if you switch brand antennas, that you independently match each antenna for the application of the vehicle it's going to be used on. I want to show you the differences between the vehicle doors open versus the vehicle doors closed. Now, every vehicle is going to be different. It may have more or less impact on your installation. It really does depend on the vehicle and the antenna being used. But this right now is the SWR with the doors in the closed position. And as I'm transmitting, I'm going to open up the two rear doors. See, it went down a little bit. See what happens when we open the other one. It fluctuates a little bit. So it's not too extreme on this particular vehicle, but on certain vehicles, the change will be much more significant. So make sure that when you're doing an SWR check, that you remember to close the doors every time you recalibrate your meter and go to check the SWR. Now, the sensitivity on the doors open and doors closed really does depend on the frequency range. On a PEG radio system, since we reside in the 30 to 50 megahertz range, that's considered VHF low band. You want to close those doors. The reason why it matters on the low frequencies and not the upper frequencies, such as UHF up in the 450 megahertz range, is because on the higher frequencies, that antenna tends to only use the ground plane surface, which is the reflective surface of that antenna, on the horizontal surfaces only. So that would be the roof surface. On the lower frequency range, the ground plane requirements are much more, and they tend to wrap around the sides of the vehicle. So when you open up the door, it actually disturbs that RF or that radio frequency pattern, and it actually changes the standing wave ratio, or the SWR, on the antenna. So on our systems, on the PEG radio systems, or basically any systems, any antenna systems that you're tuning that are under 100 megahertz, you want to try to remember to close those doors, because it will make a big difference. Okay, well, I guess that's it for now. I hope you found the video helpful, and thanks for watching.